Hello everyone, welcome to the e-learning platform of Apex Institute. Here is the information regarding the instructor and the course. In this video we will talk about the proof of equation of one-dimensional motions. So let's start with that. So this is the first equation of motion that we are going to prove here. The letters have their usual meaning. So to explain their meaning, this u is the initial velocity. So let's start with this. Let's say we got a particle over here initially, and then over the time this particle moves from initial position to some later on position. So this called that x to be 0, and the velocity it carries is u. Acceleration is a constant and a. Later at time t it might be at this location, and the velocity will be v. So v is indicating the final velocity, a for acceleration, t for later on time. So we know, like, if it is the location is x, we can say velocity as per the basic definition is dx by dt, and acceleration as per the basic definition is a is equal to dv by dt. Now to derive this first equation of motion, we can carry with this second definition, that is the definition of acceleration. Now from that definition we can write dv is equal to a dt. Once this is a differential equation, we can go for the integration both the sides. So having integration symbol, we can use the limits for this purpose. So limit has to be initial velocity. Initial velocity is u, final velocity is v, initial time is 0, final time is t. Using the rules of integration, we will find that the left hand side is going to be simply v, and the limits will be there. And on the right hand side, a being constant can be taken outside, and t will be integration value, and it will be running from 0 to t. So we can put the limits 0 to t here. We can put the limit u to v there. If we go further, then you will find is going to be reduced to v minus u is equal to a in bracket t minus 0. By simplifying or rewriting this, we can write v is equal to u plus a t. Now if you look at carefully, this is the equation we are supposed to find or derive. So that's a derivation or proof. To prove this second equation of motion, which is s equal to ut plus half at square, we need to use the first equation that we have proved, v is equal to u plus ad. Now going forward, we can replace this v as dx by dt. So if it is dx by dt, so this is going to be equal to u plus ad. Now separating variable, we will find this dx will be equal to u plus at dt. Now then we need to go for integration both the sides and substituting the limit. Initial limit will be position of, let's say, 0. Later on it goes to position s. This was a 0 time, and then this time is t. If we can carry with this integration, we will find this left hand side of integration will be s minus 0, and right hand side integration will be distributive in nature, as we know. So first will become u dt. U after integration will lead to simply u as a constant outside, dt will turn up as t, and then will be limits running. Then this will be a outside, and integration of t will become t square by 2, and the limits running. If we place the limits, so you'll find this limit is going to be running from 0 to t, and putting the values, we will get s is equal to ut plus half at square, where a is a constant acceleration. So that becomes a second equation of motion, and hence the proof. Alright, so we can use first equation to prove the second equation. Next slide we will prove the third one. Thank you.